All right, P4-13 always has have the issue of when you cut a cylindrical shape through a solid, is that radius really of the circle as it was projected normal to the right plane in this case, or is it 18 millimeters lying on that face, generating more of an elliptical, and then cutting through? So we'll do both ways as a what if. The rest of the geometry, not really anything that raises any concerns. All right, so this is a metric part. We're building the triangle. So I'm going to go with the center line. If we come over and turn the for construction off, well, that affects that line. You can still go for construction and turn it off, but then it jumps back to for construction. So a lot of times what I end up doing is just kicking out the line command, okaying it, and then going back in with a new command. So let's mirror. We will get our base at 60, height of 51. That's an interesting number. And this is going to extrude across the midplane of 50 millimeters. All right, so this is one of those cases where it doesn't quite look like the drawing. All right, so again, I said it wasn't critical, but there are times where it helps with your perception of the model. This is one of those tools that will help us change it. As long as we catch it in the first 2 or 3 features, it shouldn't generate too much in the way of an error. All right, so when I come over to that sketch and edit the sketch plane, all right, so go through that again, right mouse click on sketch 1, come up and over to edit sketch plane, and we're going from the front plane to the right plane. So it's going to keep its relations and dimensions, but basically rotate from between those 2 planes. All right, so we're going to save the ellipse or the cylinder to last. We have then, since both of these are cut through all, select the midpoint, control select the top edge, go to midpoint. Width is 20. If we wanted to check against the dimensions, outside edge is 15, and then the depth is 22. All right, outside edges have a depth of 8, height of 20, and height of 10. All right, and what I was looking for is to make sure that those dimensions were also normal. All right, so well, let's go with the rectangle with without doing the symmetry, without the mirror. And in that case, we would go collinear. All right, I'm going to stay with my collinears. And then before I get out of the selection, I'm going to come over and make equal. All right, so this is going to be extrude cut because this is in the center of the part because I was drawing on the front plane. We're going to go through all, but also have the ability to go through all both, activates direction 2, and makes it a through all as well. All right, so what I think is going on with the radius of 18 is that it is normal to the right plane and then going through the part. So we'll do that one first. And I can go back into the front plane. And we'll just draw a circle. Put a diameter of 36 on it, basically doubling the 18. But I want to see it as a radius, so I'm going to come over to the dimension and the liters and switch my diameter to a radius. And then, like previous, extrude cut through all both, and that makes the shape. So basically that becomes an ellipse and it has an arc length. All right, so that would be the solution that I would expect. Since it's not maybe 100% clear, or it is, and I'm making it more complicated, we're going to go into the sketch. I'm going to do the same circle on the leading edge. And we'll go the same 36 back over to liters before I click out of anything, before I lose that dimension, and we go over to the radius value. Also notice it went from that, let's go back into that, click on the dimension, it went from the linear to diameter to radius, and then potentially the foreshorten in the arrow direction. All right, so the issue here is that if I just go extrude this, it's going to go through as an angle. But if we do an extrude cut and tell it through all, but another box that we kind of jump over quite often is direction of extrusion. I'm going to pick that leading edge so that it brings that geometry through. Then now instead of having an arc length, I end up with a radius of 18, but looking at it on end, I have an ellipse. All right, so one of those two solutions is going to play out. I think the cylinder in most cases will prevail, so cut extrude 2. Whatever, if this is interfacing with a shaft or along that lines of the geometry, then I can suppress and unsuppress and look at both what-if conditions. This is my first choice to take into the assembly, and if it proves out, I would come back and delete extrude 3. We go into the assembly and realize that it's clearance for some other piece of geometry. Then I would go suppress, unsuppress, and delete, cut extrude 2. So it gives you some options on those suppression states. And the suppressions are the third item in, and the down arrow is to suppress it, which treats it as if it's not there. And the opposite is the up arrow, which is to unsuppress and bring it back into play in the model. All right, so let's fly 14 in here. All right, so a little bit of an angle, back angle 30 degrees, so those could be parallel. Based on our geometry, this end face, even with all the cuts, is still looking like the best choice to draw from. So unlike last time, I will start on the right plane and double click the metric, go into the right plane, open up the sketch, and let's see, that one comes up. So usually rather than trying to hit the origin with something that I'm going to put at the midpoint, I'll just go ahead and draw it off of the original ways, do the select, control select, and get it out of the way as a midpoint. All right, so 55. Let's come back over L on the keyboard to get into the line command. That comes up. This one has a little bit of a step, comes up and over, and we said that those were parallel. Well, I didn't pay attention to the inference lines, or it would have given me parallel. And since I didn't, we're going to select, control select, and go to parallel. All right, so the in-between, endpoint and line, going this direction, 30 degrees. All right, so the issue there is that we're looking at 30 degrees both sides, and if you were looking at this included angle, I would tend to believe that that was 30 degrees. Problem is that, it's a much flatter angle, and I'm really not buying into that shape, and we're going to go to the adjacent angle anyway, so let's go 60 degrees. All right, so if I had grabbed the top, I could have done 30 on the interior. I don't know, it's kind of a toss-up, but pay attention to your angles. All right, overall dimension is 50. All right, so those are looking pretty good. Let's see. let's come off of that top center point, and we'll just come down, make sure that it intersects. All right, so 15 and 30, and another 15 would be 60. And that came out 60.77. So that's an issue. All right, with both sides being 30 degrees, but the slight 10 millimeter offset, no, that should still be parallel. So there's a rounding error on the 60 millimeters, or we have to adjust the angle. So since we're given 15 millimeters, we're not going to be able to go to symmetry across the midpoint, and from that edge out, if we're given dimension, it would be the 15.77. So that being the case, let's go ahead and get that up to its midpoint. We'll switch that from midpoint, so I'm highlighting, identifying the little box, and we're going to go from midpoint to coincident. All right, so the angle coming up, well, yeah, let's go ahead and make those symmetric. All right, we'll get some dimensions in there. So depth-wise is 7 millimeters. And then looks like the length of the leg is 10 millimeters. And then the overall was 30 millimeters. So that'd been all right, 30 and 10 and 10. All right, and then from the outside edge, which kind of makes me cringe on the manufacturing, would probably not detail the drawing this way. As far as an edge that I could pick up and actually cut this geometry, I would probably be coming off of this edge. Then again, the setup's kind of complicated to cut that V, so. All right, so 30, and then let's throw in, now let's throw a 9 in at the bottom, so it turns out that it's not symmetric, that it's going to shift. Okay, so let's go back and make another correction. Oops, I was in the right view, so I need to get back over there. All right, so here's my symmetry. And I think I got the line, so let's just make sure symmetric. 0, come down and give it a dimension of 9. All right, that shifts it over, and then if we want to double check our numbers, it gives us the 1577. All right, we go into the extrude, we pick our region. As soon as it sees that overlapping, that intersecting geometry, it's going to automatically put us into contouring region. All right, so depth is 60 millimeters. Try again. All right, so rather than going back into the command, if I can find the blue dimension, and for once I'm just not seeing it. All right, so let's get back in. 60 millimeters. Yeah, there's a 10 somewhere, but I just couldn't find it. All right, so front plane, open up the sketch. We'll go from corner to corner. And we have a depth of, that's to the step. We have a depth of 20. And we have an assumption that it's halfway. All right, so if it's halfway, I can go midpoint, and we'll make those coincident. All right, so we'll make sure that it gets back to the top. Okay, so coincident, features, extrude cut. Again, it's in the interior of the part. Through all both. And make the step. Okay, so lost my perspective a little bit, so rotating over. Since that was centered, then we'll go, not select chain, select midpoint, control select midpoint, depth of 6, and width of 20. And we'll just let it go through all. Okay, so let's see if both blocks, yeah, we can go ahead and get back into that one. So edit the sketch. Again, make sure I'm looking at it from the correct perspective. So this one's just going to be a coincident. We have a width of 20, depth of 10, and from the lower edge is back 25. And none of the features are active because it's already a feature. We just go ahead and accept it. And other than it looking really weird when it jumped, that gives me the correct geometry. So we'll give it a Control S. Make sure we're in sequence. And 4-14. All right, we'll fly these back in. All right, going to 15. Interesting chamfer manufacturing-wise. This comes back to Sinker EDM to get that to be sharp, or a lot of 3-axis work to make a very minimal radius in that corner. That being the case, we'll take a look at what it would take to machine it or to increase the manufacturability. All right, so this is a metric part. Let's go with the top plane, and let's just stay rectangle, since that's not my main concern right now. So 50, 65. All right, we had 15. On the width, and I want to use chamfers rather than than geometry. So let's go with, let's just take a look at what this does. Okay, so 15 and 25, so that's a 10 millimeter chamfer, 2 places, and we're 15 millimeters back. Okay, so we'll get the visual part of this out of the way. And 20 across the back. All right, and then there isn't really anything to set to equal, so we'll go with a center line, and then line to line. Make sure I'm getting the lines, center line, and we'll go symmetric. All right. So first feature is to extrude to 12. And we'll pick the contour. All right, and then sharing the sketch, we'll go back into the extrude, pick the region, and its overall height then 23. And 12 would make it 35. Okay, so we'll go back and double check that number by selecting the edge, looking down here at the length, making sure that it reads 23. All right, so each of these corners then, let's go ahead with the chamfer. And 10 millimeters already in place. Oh, I didn't add that one in. That's why it looks narrow. Okay, so double click. And because I changed it outside, we got to rebuild. And other than that, it looks kind of strange. Let's see, double check our numbers again. 50, 65. Oh, 50 across, so 65 by 65. That makes more sense. There we go. And rebuild. Okay, so I missed the 50 across the back plus the 15. 35, there's the 65. That's the one I should have keyed in on. All right. So the hole geometry, diameter of 8. Problem is it's not given a depth, so the assumption would be that it goes all the way through. So that being the case, let's make it a hole wizard so it's easy to change. So picking on the face, hitting the S key, and going to hole wizard is about as the same as coming up to the command manager and going to hole wizard. And we're going to be putting in a simple hole. ANSI metric. We'll stay with the drill sizes. Already in 8 millimeters. That's handy. And we'll go up to next. Set our position because we already picked a face. If it asked for a 3D sketch, just come over and pick the face and then set the point. And then our dimension from the point to the edge will be 15. And height will be 18. Okay, so as a through wall, that's pretty much what we're looking at. All right, if something comes up and we decide that, well, it was a blind after all, blind hole, we could edit the feature and change our ink condition to blind, give it a depth, and it would also include the drill point. Okay, so looking pretty good up till there. Radius of 14 in 2 places. And we'll go to fillet. 14 millimeters. Comes up right to that back edge. So a little bit of deformation on the edge, but largely that's going to give us our shape. All right, so we talked about this mitered inside edge. I would have to sync or EDM to get that geometry in, or generate a 3-axis. A large, let's see, a large 3/4 inch 90-degree countersink drill mill tool might be able to get in there, but I would need a fillet to match. All right, so we're going to come back from the 14 millimeter, and if I were to put 375 inches to match my geometry, that's pretty much what I'd be looking at. All right, and then we have the same problem is I can't cut square corners with round tools, so at the very least I'm looking at maybe a 1/4 inch, 6.35. All right, but I pretty drastically changed the part, so I'm really going to have to check the functionality and the fit. As far as the blend, you know, maybe a little more on the radius, and the blend cleans up quite a bit. But I made kind of an assumption there that the round tool, now it's going to be narrower at the bottom and tighter at the top. So that even that's not a really good representation of the cut. So let's suppress those assumptions. Now, it's one of the reasons I want the chamfer at the end is because of that geometry. And let's see if that went to the back side. Actually, let's go ahead and put the triangle in. I really want to see what that geometry looks like, so I'm going to take a little side trip here. 10 millimeters on the depth, and then those two are going to be equal. All right, and I put it on the wrong face, so we're going to edit sketch 4, edit the sketch plane, put it from the front face to the back face, and then the sketch becomes a revolve cut. The axis of revolution is the vertical, and we'll let it go ahead and trim it all the way through. All right, so that would be if it was 10 millimeters. So if it was 0.375 inches, 9.53. Now that one's barely going to make it, but it gets us in the realm of the geometry. So let's go ahead and sketch that in. Actually, see if we can share that. Features. Oh. Yeah, let's get out of that. Sketch 4, extrude cut. Make sure it's going the right way. And give it an up to next. So it'll come off of that angle. And I did it again. So we'll have to move that out. All right, so the issue is going to be that a 375 radius 90-degree tool coming right to that edge is not going to have a lot of cutting action. And so it's going to be pretty bad in our geometry. So that being the case, going to have to get out of that again. Edit the sketch plane, move it to the back. We'll go ahead and set it up as the revolve cut, give it the axis of revolution. Alright, so this is looking a little weirder as we go. Make sure that I've got the cut in place, extrude cut, reverse the direction, through all. Here we go. Alright, so that leaves the last of the geometry. We'll go face to face. Alright, so not really, the fillet's not going to be the same as that round cut. Alright, so right plane, yeah, kind of out there. So let's just go ahead with the sketch on that face, switch back into hidden lines removed. Should be able to pick all of this up as existing geometry and tie it together. Alright, so that's floating out there. We're going to extrude cut, and I'm going to give it an up to surface. We could do vertex, and basically chop off those two corners. Alright, so looking at that, there has to be an easier way than what I just told it to do. But my what if scenario, that gets me there, and I'll have to think about what that geometry really is going to look like. And then we're back to having the same issue of, well, if that goes to different geometry, how is it going to pull in and come back? Alright, so we really need to decide what we want to do with that geometry. Oh, and then the 14 millimeter. There we go, that's the one. Alright, so double clicking on it lets me take a look at it. Alright, so still some issues, but yeah, got to go through those considerations and figure out the design intent before we get too far into the next phase. 15. All right, one more. All right, so we have a couple of angles and 45 degrees off the face, notch end. So pretty much this back geometry, build up the other geometry, do a cut through. And in metric. Okay, front plane. Up, over, down, down, angle. All right, 70 millimeters across the face, 55 on the height, 45 on the angle, 25 back. And then if we want to include the notch, and the notch has that weird, yeah, the notch is a little weird. So we're going to save for the, for it. Basically, it's coming off of the angled rather than off of the base datum. All right, so 15 millimeters. And we'll wait on the notch. So over, missed the, didn't need an angle there. So first thing we'll do is go back and make that vertical. Distance is 15 millimeters. We have a distance of 50 and a height of 23. So no angle, just dimensions. And then this comes out from an overall of 50 to minus 15. 50 minus 15, 35. All right, and then pick up the next angle, jump back over to the hidden lines. All right, so starting at the edge, coming out to the opposite. 30 degrees, I can leave that open. It's going to be an extrude cut. Make sure the direction of the cut is in the way that I want it to go. Becomes a through all, automatically goes to through all both. And gives me my outside shape. Alright, so this geometry then, well, I'm just going to go ahead and make it a rectangle. Now, once it completes the cut, it's not going to be, oh, and it's not going to be linear either. All right, so we'll try again. From that point, well, nope, we're not up to points yet. So depth of 15, and then we need 22 back to that point and 15 to the other point. So, all right, we're going to go into the point. I'll pick up the edge and then make it coincident with the intersecting. And now I can go 22 from point to point. All right, so basically the vertex of the edge. Make sure that I'm getting a good alignment, 22. And then from point to endpoint, check the alignment, and that was 15. That's going to be an extrude cut through all. And we'll save that one, 416. So another one of those, not quite sure what the function of that part is. But there's some things that we're going to have to look at, interior radiuses and corners, to clean that up for manufacturing.